I'm opening up a Parasolid, and it is asking me for the default template, which is a part inch. You bring a Parasolid into SolidWorks, it's going to ask you to run import diagnostics, and depending on the system that it came out of, you may have gaps or faces, so this is a chance to repair those, fill the gaps. We don't really need to run feature recognition. If there was geometry that we might want to change, hole location, size, we could bring that specific geometry back into SolidWorks and make those modifications. So going into Mastercam, the lathe mill turn module pretty much aligns the part along long X, and I haven't really figured out how to change that system. It's a lot easier to change the part into that orientation. So under features, let's see, when you turn direct editing on. And so direct editing, I went to move copy bodies. Body to move is our part, and this is not going to be a translate. We're going to come on down to rotate, and we'll make sure that we're rotating about the origin, and then the Y direction will be 90 degrees. We'll see what the preview looks like. We're not copying. Go ahead and place it. So the other option is to import this into an assembly, in which case we would just save this as a part file from the Parasolid. And once it was in the assembly, then we would apply the mates to get it into that orientation. Alright, so over on Mastercam, we have the default machine group is still set up as mill. Pretty much needs that one machine group to start because we've set it as a default. Come over to the Mastercam tab and kind of look down through here. We're not really picking up, or I don't see the tools, machine definition, control definition, those types of items. So I'm going to go over to tools, and just off screen is the Mastercam, and we're going to go to lathe machines, and then can set up for the default. And then under the files, we're going to replace it with the 4-axis mill turn. The post updates, the lathe tools, inch tools, those are all in place. Tool settings, go into program 1 from tool, assign tool numbers sequentially, default tool, or warn of duplicate tool numbers, sequence number of 1 and 1, and we'll select a material. Go into the lathe library, and we'll make this out of 6061. Alright, where this comes in more important is when we get to the feed calculation from material. Otherwise, it's just a reminder of what material we were programming for, setting up for. Alright, so under the stock properties, we have a cylinder, and I'm going to select the OD, so 2.5 inches. Length we'll select from 2 points. So we need an edge so that it can find the center, and an edge that it can find the center. So 4 inch on the stock. Let's go ahead and give it a little bit more so that there's overhang away from the chuck. And there's no adjustment on in the position along the z-axis. So if we preview the lathe boundaries, see that it's a little oversized. We're not really concerned with cutting the stock back behind this chamfer at this point. So if we were, we would have 2 3/4 inch material, 3 inch material, something to start off with. That was oversized. If it was just a little bit oversized, we want to take that cleanup pass, maybe 2.52. Going into the chuck job properties, then the diameter 2.5 inch if it's not already set, and Z position -5 pushes it back to the stock. Not so concerned if we're working really close to the chuck jaws, then we could be a little more concerned with the actual geometry. For representation, we have enough information to pick up that step. Alright, so we end up with the DZ plane, so diameter and Z direction, and we're ready to start putting in our operations. So machining would put in here 1.344, so that was like a 1.5 12 or 1.5 8. No, that's probably too big. I have to go back to the original drawing to see what the internal thread was. So question is, do I want to bore and then thread, machine through the outside, bore back to the face? Really, the question is, which way am I going to push the burr as I'm making these cuts? And then the interrupted cut on the bore is also going to have the potential of making the surface not as clean, but since it's a thread, it can go either way. I guess the other question is, since we're going to machine these, do we have a tap that size that can go back and clean up when we do deburr, push through the outside? Alright, so let's go with the mill geometry. We're going to pick one of these faces. And so we're perpendicular to the face. And we need to pick up our initial piece of geometry. So I'm pretty much just deciding which of the contours I'd like to start with. Alright, so under Lathe Toolpaths, we're going to come down, and right at the edge of my screen is the C-axis, and of course it cascades just past the edge of the screen. We're going to go with a cross contour. Okay, so chain, nope, that wasn't what I wanted to select. So back to the selections, get rid of the pre-select. We're not getting into propagation, but I do want to go from face to face. Okay, and then I can look at the chains. And one of the things that's handy is to either have the wireframe shown or be able to switch into wireframe quickly. And on the chain, we can see that the direction of the cut is climb, and the arrow is pointed in mostly the correct direction. Chain 2, also climb cut, and pretty much pointed in the relative direction. Alright, so enter new CNC name. We'll stay with the default. Try and get these windows over into the current screen. It's showing us a preview that this is a back and forth motion on the C-axis cross contour. Pick up a tool, and we can go ahead and do the mill operations first, since that's what we're kind of focused on. And we'll bring out the filter, make sure nothing is selected, and then go for the end mills. And so a 1/2 inch flat end mill. And we'll want to check the max RPM of our live tooling heads. The tooling blocks usually have some type of limit through the turret. So let's say that the spindle speed makes it to 4,000, and the surface feet per minute, then that gives us 523. Feed rate, we don't want to be too aggressive on the first go around, so we'll set it at 10. Plunge rate can also be 10, and this is to mill the flat. All right, holder is default holder extension, probably a little bit long on the projection. So let's go to 2-inch. Going into the cut parameters, compensation, yes, I want to be in where. Don't really care about the look ahead. Internal corners, external radius, nope, don't apply. No stock to leave on the walls or the floors. Not really concerned about depth cuts. Lead in, lead out. Going to adjust the start and extend. And we need to extend past the radius, so I'm going to give it at least the diameter, and we're going to apply it to the out as well. No breakthrough, but on multi passes we're going to rough probably 3 times with a spacing of 0.3. And on each of those passes, then I should have 1 through the middle or close to the middle, and then 2 additional passes engaged in the end of the part. We'll see where that toolpath falls out. Let's see, finish. We can do 1 finish pass with a spacing of the last 10 thousandths. And then the linking parameters, clearance. I'd like a little bit more, so maybe 1 inch. Retractive 0.1 from the face, feed plane also 0.1. Top of stock incremental 0 should be the selection. We'll have to see where that one falls out, because really I'd like it to be at the diameter for reference, but the depth, that should be where we selected, and its incremental position. So see what we get. And about the only other thing would be the coolant. We haven't been setting that all too much, but the flood right now it's set to ignore. We'll leave it. Alright, so first toolpath through the center of the part, and then the tool has been told to stay down. Alright, because I'm not seeing the retract, so it's going to conventional cut back through the geometry. So we'll go back in. And either we didn't give it enough of a clearance plane, or the feed plane. Okay, machine finish passes at final depth, other just keep tool down, uncheck. And we'll regenerate the dirty operation. Alright, so that 100 thousandths is coming up off the wall, and even though we've taken a pass, then the rapid will be back to the start point. So back into the linking parameters. The rear track plane, we gave the clearance plane a good amount, so let's go by halves and we'll refine this as we go. And regenerate and see if that raises us up enough. Alright, so my approaches and my clearances and the rapids all occur above the stock now. Okay, so I'm going to hide that segment. We need to create the geometry for the spot face. So since I'm going to use that wireframe quite a bit, I'm going to go back over to Customize, and we'll bring up the right-clicking in any of the gray areas and picking Customize. Go back into the commands, and we're looking for the View. And under View, Hidden Lines Visible, Wireframe. That's what we want. I'm going to place it in between. So I have ability to switch from the wireframe to the solid, and that way any of the internal toolpaths, kind of the not real clear toolpaths, will show up through the wireframe. All right, so back to the toolpaths, back to C-axis, going with the cross contour. All right, and really the cross going across the axis. Pick up for the pocket. And I think we'll be able to set this down and go around our geometry in one shot. It might need a pocket. Okay, so we have the chain, direction is to the interior. We still have the tool, the settings, holder, cut parameters. Lead in, lead out will change. So let's go to 90%. Nope, hitting my caps lock key instead of the tab. Alright, so the tab key cycling through, no ramp height. Radius, we'll go with 0.25. And the sweep should be about 120 degrees. And we'll transfer those over. No multi-passes on this one. Linking parameters stayed the same, so we'll see what we get. So it kind of crosses over a little much on that sweep. So let's go back and check our lead in, lead out. So 0.25 sweep of 120 degrees. Make sure that all comes across. And regenerate. Alright, so pretty much plunging at the center, going around, coming back to the center for cleanup. If we'd set that for, well, if it was a deeper pocket, or we'd set that for the actual pocket, taking the multi-passes, we would end up with about the same thing. Alright, so I need to go over to the drill. So lathe toolpaths. Still going to be C-axis, except now we're going to cross drill. And we'll pick up the edge. Make sure that we have a center point. And the tool is going to be for a half 13 tapped hole. So come over to the drill, make sure it's active, and we're looking for a 1/27/64. Surface feet. We'll see if we can get to 200, 1810. Don't need all the extra decimal places. 12 doesn't look too overly aggressive. Cut parameters will go into the peck drill, and just give it the first peck of 100,000 should carry over. So let's increase these 0.5, 0.25. Really the material and the depth from what I picked, and we need to make sure that that goes in far enough. So let's give it 0.5 on the wall, and that'll probably be a little too deep. We'll come back and we'll adjust for tip comp if we need it. Go ahead and accept. Alright, so I need to hide, turn off the display. And doesn't look like we got the geometry in there. Okay, so I'm not seeing the drill path, so told it about a -0.5. No, still not picking that one up. Yeah, I think it would pick up those. Well, let's see where the top of stock, where it falls out. Yeah, 0, incremental. Well, maybe we do need all of the subsequent parameters there. Okay, so was I was checking the numbers and did not get the display, so that should be enough for the tip and to make through. Probably not enough for the tap drill, so that becomes a little bit more of an issue. All right, so one more check. Let's well, you know, at this point I'm focusing on all of the C-axis moves that for the mill part of the turn. If we've opened this up and we've opened up that bore to with the thread, then this will break through and pick up that geometry. So that being the case, probably don't need to make it any deeper. Alright, so back into the lathe, Z-axis operation, cross drill, and we don't have any, let me jump back into that one real quick, no point selected, yep. Lathe toolpaths, C-axis, so face contour, face drill would be on this in geometry, C-axis drill, in geometry, C-axis contour is what we're going to look at putting in for the rotation. Bring the end mill in, engage it into the O-ring slot, and then rotate the part to generate this geometry. So, all right, so we're back to lathe, toolpath, C-axis, cross drill, and same point. Toolpath, select library tool, turn on our filters, make sure that we're selecting for tap, and we're going to pick up for the half 13. And it can be a spiral point tap. Alright. So for that engagement, 130 RPM. Shows a feed rate of 10 inches per minute. That's a good place to start. We may speed that up once we look at the rigidity machining conditions. Go to the cut parameters. We're going to switch over to tapping. Don't really need to dwell. Link parameters. Again, we said that the inside was opened up. On a spiral point tap, we have to be concerned with the lead and the kind of the unusable first 2 or 3 threads. So actually that would probably need to be a little bit deeper to get all the way through, but we can make that adjustment at the controller and bring the information back to this program to update. No tip comp, and we'll double check that it made it in there. Alright, so that gets us the tapping operation. Alright, turn off the displays. Oh, turn that one back on. Now we'll turn off the displays, and we need to pick up this this geometry for for the rotation. So what I'm interested in is in the plane manager. We'll kind of find a spot here, and we have the DZ, but if I look at the front plane, the back, and actually that was DZ. If it'll allow me to pick the plus D plus Z master cam top as a transformation, then we'll take everything in the toolpath group and transform it in one shot. Okay, so I want everything in toolpath group 2. We're not doing linear or mirror. We're going to go into rotate. Tool plane method. Okay. So tool plane. We want to go by operation order. So let's see, it's going to do, it would do all of the mill operations, and then it would do all of the drill operations, and then all of the, now we're going to have to look at verify. I always get those two mixed up. Alright, so into the rotate, we're going to have a total of 6. Starting increment from where we're at is 60 degrees, and additional increments 60 degrees. Rotation tool plane, master cam top. We want to make sure that Z is pointed in the area of our rotation. I'll see, nope, it didn't take it. So master cam top, Z is still pointed up, and it's rotating about that axis. So we need to find an axis in that that group. We'll to the face. So if this is the top, it's either going to be the right or the left. So let's see what the right side. All right, and so again, it's kind of one of those logics that I'm having trouble following, but the right side, the Z points in that direction. So if we come back over here and I look at the right side, well, still picking up a D and a Z, but Z is in the correct direction. And we're rotating about Z when we perform the transform. Okay, so that'll get us the majority of our Z-axis moves. Now we'll make sure everything is selected. Go and turn off the display. Turn on the display. Turn off the display. All right. So for the lathe operations, then. So we're going to do the drill and the bore first. So let's come back, and we're going to have to pick up the tool numbers, station numbers for the tooling blocks. That is going to hold those tools. So lathe operations. Let's go with a drill. I want to open up that as much as possible. We had 1 in 11/32, so we're looking for probably the 1 1/4 diameter spade drill. Inches per revolution, feed rate 10 thousandths. It's probably a little aggressive without a pilot hole. Let's back that down a lot. Surface feet per minute, or RPM at 200. Let's see, if we were punching that through, one and a quarter, and 200 is probably a little on the slow side. Let's go up to 400. We have to run, I need to run those numbers, and we'll give it a max spindle speed of 1,000. Since we're not using the constant surface speed, max spindle speed is more of a reminder for me. All right, and then the issue with the drill is that it's going to contact the tool holder before it gets completely through the part. So depth is -4 inches, And are we compensating for the drill point? The drilling cycle will be a peck, and we'll go with the 100 thousandths pecks. Alright, so yeah, 0.002 inches per revolution at 400. That's still pretty aggressive, but we'll see what it gets into. Alright, and then no custom parameters. Alright, so it almost makes it through. I kind of see that the tool holder is impacting back over here. So if we go back to the drilling and the tool geometry, let's see, we have 5 inches overall. Let's bump that up a little bit. And we know that the part is 4 inches, so 5 inches to the shoulder, 4.5 inches to the end of the flutes. Alright, and then on the parameters, we can go back to the drill point. Didn't quite run the calculation. Let's see, 0.25 clearance, retract 0.25, and just go ahead and let it run to 4.4. And we should see that it just barely comes out the backside. Alright, so here's one of those points where, yeah, tool holders and the drill are still getting into my part. So I should have gone ahead and opened it up quite a bit more. So the holder length, 8.75 overall. Now let's see if it's holder. Okay, so no, still didn't quite update. Alright, so I have to look at that geometry a little bit closer. It is going to show on the verify that it is hogging that material out though, so tell it to go ahead and regenerate. Oh, there we go. Tell it to regenerate even though it sees it as a clean operation, to go ahead and update the stock. So we've got enough length on the drill now that it's not how the holder is not gouging into the outside face. All right, and then we're going to go into the boring. So have the rough on the face, ignore the front face, ignore the back face. Set the chain 1. Well, it sees the interruption. Alright, so chaining options, chain tolerance, profile. I need to find the rotation or the shift in orientation that will pull it back, or I need to create a sketch that shows that it is continuous. Let's see, where are my tooltips? Direction, side to cut. Alright, so I'm not seeing it. Okay, so I think we're just going to have to go ahead and try it, and notice that the arrow is pointing to the outside. Concern would be it's going to jump over that 400 or so thousandths, and then when we go in either with the rapids or with the next step, that it's going to try and skip or rapid through that. Alright, so boring bar, we need something a little on the large side. So we'll go with ID rough minimum 0.75. It's pretty much a standard. Feed rate 10,000 cents per revolution, plunge feed rate 5,000, spindle speed, constant surface speed. Well, we'll go up at least a little bit on that. And max spindle speed, let's tell it at 1600. Alright, rough parameters, equal steps, depth of cut, let's go 50 thousandths, minimum depth of cut thou, stock to leave in X, for the rough 10 thousandths, don't need to leave any in Z, entry amount of 100 thousandths, we'll go with the computer compensation. We'll do no compensation, at least initially, for the rough. Angle at 0 degrees, and cutting method one way. Alright, so it seems to have picked up, well, we have the first cut, and then the, okay, can't say that I understand what that one's doing. That might be the wrap it out. So that one went all the way to the drill chip, but that's going to be a collision. Okay, so that being the case, I'm not thrilled with the way that generated, so we're going to go back over into the SolidWorks side of things. Open up a sketch on the top plane. And if I can go coincident to both ends, then that will give me a sketch to work from, and we'll call that bore ID. Okay, so going back into the to the rough, primary. Well, let's go to the geometry. Clear the selection, pick my sketch, select the chain, arrows into the interior, go ahead and hit OK. Let's regenerate that. And it still picked it up, so go back and look at the parameters again. We opened that up with a 1.25, we're going to 1.344. That doesn't seem like that even at 50 thousandths. Okay, maybe. Well, let's drop it down to 10 thousandths. Yeah, okay, so it would do that in potentially one pass at 50 thousandths. So okay, so let's grab the drill. Okay, that was the drill toolpath. Okay, so that was what was trying to confuse me. So we're in, it comes out, even at 10 thousandths. So that almost means we just go right to the finish. Alright, so lathe toolpath, finish, pick up my same sketch, look at the chains, make sure the direction is correct, flip the side to cut. I'm still going to go with the ID rough, minimum 0.75 diameter. And we want a decent finish on this, so let's slow it down to 1/1000th of an inch per revolution. Fairly slow, but we can go up to 600 on our constant surface speed, 1600 for our max spindle speed. Finish parameters, step over, stock to leave, none, none, number of finish passes, 1. So if we needed a spring pass, we just up that number. Alright, So it goes in, makes the cut, opens up the geometry. Alright, lathe toolpaths. Going into the thread, and we need an internal threading tool with enough depth. So now we have 1 1/4 anyway, so 1.34 on the opening. Feed rate at 10 inches per minute, spindle speed at 200. Well, that should pick up from our thread parameters, but max spindle speed, probably 1,000's on the heavy side. So thread form, let's select from the table, and we had a minor diameter of 1.344. So 1 1/2, 6. I don't see the 1 1/2, 8. Which is what I think I called it out as, but 1 inch 8, no. 1 3/8, 12. Not finding anything lining up to that minor diameter, so I have to double check that call out. In position, we're not going that deep. Actually, well, I selected my sketch, so let's bring that back 3 inches so we have 1 inch of thread. Let's see what that looks like. And lead, taper, minor diameter. Now let's see if we can adjust those on the fly. And not quite 160, so yeah, that looks pretty good. Canned equal areas or equal depths, we'll go with equal areas. Number of cuts 5, stock clearance, acceleration, lead-in angle, and 1 spring pass. Toolpath starts with tool embedded in the stock. Modify the toolpath outside of the stock pin. Yes, I want to save the operation. Alright, so don't really have any points. Start position 0, end position. Now let's see what it does at the -1. No taper angle. Oh, okay, so there's the -1 inch. Wow, that's really close on the retract. Toe collision with stock. Okay, to cancel. Oops, now we don't need the catalog. I was looking for the type threading. Back into the parameters, toolpath parameter. So at a minimum of 1 inch, let's go back to that 3/4. Alright, so there's the threads. Wireframe, there's the cut. Okay, so that's all the internal geometry. We've removed most of this material, so really should be able to pick up for the chamfer. So the OD operations, lathe toolpath, finish, picked up the 2 chains. Alright, so really that would be 2 separate tools. So That's an interesting location for that one. Let's get rid of chain 2. And the arrows to the outside, let's go ahead and accept it. '80°. The tool right. We'll leave the default settings, finish parameter, step over. See how much of it can cut. Warning of the duplicate tool numbers since we picked up lathe finish. Okay, so up and over and out. Let's go ahead and save, and we'll go ahead and turn off the display for both of those. Lathe Toolpath Finish. Selection will be the chamfer. Take a look at its chain. Direction is to the outside. So we can stay with that tool, 80° right. Same parameters, finish. Clearance boundary, so we don't have enough to get in on that geometry. Alright, so now watch for the gouge because really it's coming up to the tangency on those points. And maybe another one of those areas where I'm getting it confused with the standalone. Finish, step over, we're not leaving any stock. It didn't pick up any of that geometry, but there was a way, I'm not seeing it, to pick along this edge, make that part of the toolpath, and then go into the chamfer. So we'll see how bad it gouges, and then come back on our tool. One more finish, same geometry. Check the chain. Still don't need chain 2. And we're going to switch over. Now the 80° was alright. Actually, it probably would have been better with the 35° for both of those. Let's see, that's a right. We need a left. Alright, so this one we're going to go into the left. So what it doesn't like is that we're telling it to come in on this side and go that way. Compensation direction. Don't think that was it. I'm trying to get my head wrapped around the direction. No. So we either need a tool that'll come back on that outside, or we need to have a form tool that we can just bring in and plunge. So that one's going to be a problem I have to address. And then the last of the contour, keep kind of bypassing. Oh, we didn't do a facing operation. That really should have been the first thing we did. Lathe toolpaths, face, pick up our right, facing parameters, entries, all of that, and insert the part. Alright, regenerate the dirty. Still doesn't like that last finish toolpath. Actually both of those, so we're going to have to come up with either a profile for that to cut or the geometry. So now let's go back into to SolidWorks. Nope, doesn't like the loop. Alright, let's go normal 2. Alright, silhouette edge, and accept, and then we can generate the line through. Alright, so if it sees that complete geometry, Mastercam might be able to figure out the finish. Alright, so we need the whole sketch, not just part of it. And we'll go ahead and do that to both of them. Because the 35 degrees won't get to that side, and the 80 degrees won't get to that side. It's not going to like those two toolpaths. Alright, so we're going to leave those off, but we're going to have to come up with a solution for that inside geometry. Alright, so last toolpath is back into the C-axis. So this is going to be a C-axis contour. If I did this right, this should be 093 by 053 deep. Okay, so it has the radiuses in the bottom. Typically would take those out. Double check the chain. Well, can't really tell because the contour is going parallel, either going to be inside or outside, so we'll figure it out. Alright, so tool, select library tool. I'm going to filter back to end mills and believe that I want a 3/32. I don't think we're going to make it to 5700, so 4000, feed rate of 8, plunge rate of 4. Go to the cut parameters, stay with the computer. Depth cuts, probably will go 10 thousandths at a time with a last cut of 5 thousandths. No lead in, lead out. No breakthrough, no multi-passes, linking parameters, and the depth will be to this inside edge. Interesting that that came up positive. Alright, so let's see what it looks like. Invalid rotary rotary diameter cannot equal 0. So if we go to the stock size, alright, so the rotary axis control, axis substitution, rotary diameter 2.5, I want to unroll. Let's see if it'll take that geometry. Alright, so we're kind of seeing it. Alright, the outside then was 1.67, so let's see if that's a better number. I really just like it pick up on C-axis. I don't know that it needs to unroll. Alright, so I didn't pick up the contour. Okay, so I needed to pay attention to my visual here, that the contour is going back and forth around the peripheral. So that was a bad selection on my part. So we're going to delete that operation. And we're going to go into the C-axis and make a better selection with the face contour. Alright, so let's pick up that depth. That was probably why the direction that on the parameters look looks strange. Alright, so that picture looks a lot better. Tool, we're going to go pick up our 3/32. And cut parameters, computer, depth cuts. Let's see. Five thousandths. There we go. 2,000 and 5,000ths step. No lead in, no breakthrough, no multi-passes. Linking parameters. Let's double check the depth. Minus 0.052. And we'll see if that looks better on our parameters, or on our visual. Okay, so we got most of it. The back cut on this I'm going to have to work on, so we can leave that out of the assignment. But everything else in here is good. So let's verify it. Do not regenerate and continue. Oh, that was just off screen. So came up with a warning that the error over here was barking at. Told it not to bother regenerating it. Okay, so looks like the depth got pretty thick there. Oh, it's doing all kinds of interesting things. So that would tell me that my clearance, since I'm turning it into Swiss cheese, that my clearance on those first Z-axis was not enough. And as it's rotating, it's plowing through the stock. So definitely not a desired result. That looked pretty good. Okay, so I went back through and I checked for clearances and found a couple of things with the geometry of my lathe thread tool, either the retract on the size of the tool, that that geometry is opening up way too much on the interior. So that may be one that we move to the end and check. But really, if everything's in place, let's see, we have the back plot verify, and stock setup, cylinder, 2.5 inch diameter. Let's just pick the solid. So that was the settings. Here it is, backplot selected operations. And going through this group, you can see the toolpaths and the operations, and the clearances look like it should rotate without intersecting. So it makes me wonder what's happening with the drill, or what's happening in those last operations on the C-axis to cause it to remove as much of the material as it is. So let's try it with that at the very end. One issue that I made a mistake on the design, well, there it opened it up again. So that looks like the boring. So everything looks pretty good up to that point. So the boring bar that I chose, so that'd be another one to take to the end. Alright, so let's see what I rearranged here. C-axis, that was a little more than intended, wanted selected, so be careful when you're dragging. Alright, so lathe, cross drill and transform. Okay, make sure I have the thread by itself, and the lathe rough by itself. And then the finish operations, if we look at the parameters, said 0.75, but there again, finish step over, lead in, lead out, length of 0.1, that should still clear for the 1 1/4 by quite a bit. So either that or the boring bar geometry is a lot bigger than I anticipated. So let's go to something smaller. And we'll regenerate 30 operations. Go back into the verify and diagnose which of those operations are creating the collisions with the stock. So that part looks a lot better. Removing the material. Oh, and since I defined the stock as the part, we're seeing it. So still something in that drill that is trying to go continuous. So that being the case, let's look under the parameters, go back to the rotary axis motion. That would be on the y-axis. Well, no. Well, let's see if it makes a difference on the c-axis. Just on those two. Make sure everything's selected, and there we go. Interesting. So I still have a problem with that drill axis. Okay, well, gonna have to call that one good. As far as the assignments, if the exercise doesn't play out, get it as far as you can go. Get as much of the c-axis in there as will go, and get it turned in.